Kia ora. You can also use this kit to show strong and weak acids. So for example, if we're comparing HCl and HF, you can first point out, of course, that these are molecules now. So I've shown it in the bonding and that they're all separated out, HCl, 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 and the same thing for HF. Unlike the stacked bonding that we had for ionic. So those are covalent bonds and you get hydrogen chloride in the gas. But once it's put into water, it will dissociate completely, being a strong acid. And so you would ask the students to show what would happen once you've got HCl in solution. Now the H plus is of course the hydronium ion, and then you can then ask what is the relative concentration. And by having the beaker of water, you can also see that you always have hydroxide present with the hydronium ion, but of course a very small amount, because only a very small amount of water will dissociate. So you can see you've got equal concentrations of hydrogen ions or hydronium ions and chloride ions, because that extra hydronium ion up there is very minimal compared to the hydronium ions from the HCl. And so it's a great way of seeing the relative concentration of a strong acid in solution. Now compare this to a weak acid. So again, we have the molecules, HF molecules, and being a weak acid, then it doesn't dissociate completely. So most of the HF will stay as HF, but you will have some dissociation. So again, let's make 2 dissociate. You can see that predominantly you've got HF in solution, followed by equal concentrations of hydronium ions and fluoride ions, and you've got the hydroxide ions still from the dissociation of water. And again, you would discuss with your students the relative concentration. So that hydronium ion, yes, so it looks as though we've got more hydronium than fluoride, but that is a very tiny amount, and you can discuss that. So that's another way you can use these kits. Kia ora.